Hey, Matt.
Hey, Mike.
Hey, we should continue to do the talking to each other while we record it.
We are legally obligated to do this.
I'm making it so. Engage. Welcome to Hacking the Grepson, where we are currently in the middle of discussing the famous laws of software development. Last week, or last episode, whenever it was.
Previously on
Hacking the Grepson, we talked about Murphy's Law, Brooks' Law, Hofstadter's Law, and Conway's Law, not to be confused with Conway's Game of Life. Or is it the same Conway? I don't even know.
I bet it's the same guy.
I bet it is. Okay, Conway is...
In my brain, it's always Tim Conway, the comedian, and I know it's not that.
Nope, different Conway. British mathematician John Horton Conway is the Game of Life.
And John
Melvin
Conway
is Conway's Law. Yeah. Melvin. That's a name you just don't hear anymore.
Melvin's Law.
Melvin. Yeah, it should have been Melvin's Law. That's way more unique than Conway. I wonder if Tim Conway has a law, like a comedy law. I bet you he does. What would it be? What would Tim Conway's law?
Put your knees on a shoe, and you will put your knees on your shoes, and you will become dwarf. I know. Is that Tim Conway? It feels like it is.
I don't know. Or this episode, there's more laws. There are more laws and principles to talk about. So let's get back into it with the next law that we are going to talk about is the Pareto Principle. Although you bring this one up all the time.
No,
so
you skipped
one. I did?
Postel's Law.
Let's talk about Postel's Law, and then you can talk about the Pareto Principle, which you bring up way more than I do.
I do bring up that all the time.
Postel's Law, a.k.a. the Robustness Principle. I have never heard of this. It states, be conservative in what you send, be liberal in what you accept.
And we should point out, these are not the political ideologies, liberal and conservative. This is the literal definition of them. Conservative meaning do less, liberal being do more. Right.
And this was apparently coined by John Postel, who was talking about TCP, transfer control protocol, communication protocol implementation, so like networks. And without looking it up further,
transmission control protocol. You were right.
Transmission control, not transfer. I basically, without looking this up, my gut feeling about this, even though I'd never seen it before, is essentially like when you are sending a network packet to another computer, send as little as is needed to be successful. And when you are accepting network connections, be as broad and open as to accepting what is coming into you to, be useful. Like don't put a bunch of filters and restrictions on it. That's kind of done at the software application layer, not the network layer. Take all the bytes and then let the software itself decide whether it's useful or what part of that is useful. But then when you're sending it out, only send as little. So it's like one is trying to make the other jobs easier. If you're not sending a lot, then there's not a lot to filter. Be liberal in what you accept. I don't know. What do you think this means?
I think the reason that it's got the sort of subtitle of robustness principle applies to the way I approach this, because I have heard this before. I didn't know it had a name, but it makes sense that it does. If you think about it from, I'll just keep going back to client server, because that's an easy example for most things. If my server sends some data up to my client, right, it expects the client to display it. But with clients, you might have out-of-date clients on the other end, right, that don't know how to do things. So if you upgrade your server and it suddenly starts passing an extra bit of information, you don't want all your clients to die, right? All the old ones. It can't only work with the new one. So if you take something like a JSON object or something, or XML, right? If you don't include the field at all, cool. And if you do include the field and the client knows what to do with the field, great. But what I've seen often in software, which absolutely breaks this, is the server will have, that you'll have some sort of contract between the server and the client. And one of those, the sender, whichever direction it's going to go in this case, adds a field and hits the other side. And it's like, I don't know what to do with that field, so this message is invalid. Right? It's less on the what you send and more on the what you receive when it talks about the robustness, which is if you don't know what to do with it, ignore it.
Yeah.
Right?
The whole thing is not broken because 1% of it is invalid, is what you're saying. Yeah.
Yeah, because that comes up all the time, especially in like security systems. Like, you had an extra field here. And I'm like, yeah, I know. I put it there on purpose. Ignore it. It's not doing any harm sitting there. Just don't read it.
Yeah.
Maybe there's multiple people getting this message. It's coming off of a pub sub system and you don't care about that one. I don't know, but don't break.
Yeah. This feels right in line as a corollary to our episode about the 3 pillars of JavaScript bloat, which is, yes, you're right, but at what point does the client need, in order to support a feature that the server now supports, need to be able to read that extra field rather than just ignore it? Like, at some point, there needs to be a cutoff where you start making it a thing, or am I wrong? And that indefinitely you do what you just said, which is if I start sending 12 new fields, but your client hasn't updated, so it doesn't know what to do with them, you just ignore them in perpetuity.
You just don't have those features, right?
You just don't have those features, right? But it should never break the client.
Exactly. So the way I think about it ties back into semantic versioning, which I think we talked about there. Show your major, your minor, and your patch versions. I often will have another one that's build after that, but that's not technically part of semantic versioning. Your minor ones are exactly this scenario in my mind. Minor is I am adding information or I'm changing something that that shouldn't break anybody that's using this version of the software. If you're tied into version 3.2 and I make a version 3.3, 3.2 needs to still work. Version 4 breaks backwards compatibility, and that's where you don't need to use it anymore, generally speaking, right? And so that's where this kind of would fall in play. So like your minor versions need to live with this rule in mind, or else they're not properly living up to semantic versioning.
Right. So you would agree that this is a good adage to live by?
Good rule of thumb.
There are exceptions, obviously, but yeah.
Yeah. It's a good thing to think of when, and honestly, this could apply to life as well, right? Like,
I'm seeing a trend here.
Don't run your mouth, but if someone's saying stuff, hear it, right?
Yeah.
I don't know. It doesn't apply as well, but.
Yeah. Well, no, I think you're onto something. I think you're onto where so many people think that if someone says some stuff that is either wrong or inflammatory or confusing, that you just like completely break down and can't have a conversation with them. I.e., you're a client that is now, that was an invalid input. I am going to not have a closed mind. Yeah, like, nope, connection's closed because you sent one extra thing that I didn't quite understand. Instead,
or agree with,
be liberal in what you accept and, create a filter. Don't just break down.
Right.
This is a good law. I think this might be my favorite law thus far because of how applicable it is, kind of like Murphy's Law. They're both, I like the laws when they are applicable to more than just software development, even though this had a strictly software development inception. So why don't you take us to the next one? The Pareto
Principle? Something like that.
Pareto? I don't know.
Pareto. AKA the 80-20 rule. Now, interestingly, this is a slight variation on the 80-20 rule that I'm familiar with.
Okay.
So I'll read what this states, and then I'll state the one that I go by.
Just one quick note. It apparently comes from an Italian polymath, Vilfredo Pareto. So it's, I'm messing up the pronunciation. Anyway, take us through.
Yeah. You got to do this. The Pareto Principle, a.k.a. the 80-20 rule. For many phenomena, 80% of consequences stem from 20% of the causes, right? And then it goes on to say, So the example they give here, or the kind of explanation they use is, this is the principle behind the painful truth that 80% of the bugs in code arise from 20% of the code. Or that 80% of the work done in a company is performed by 20% of the staff. That's not the way I typically see this applied. The 80-20 rule specifically is more that 80% of your users are using about 20% of your software, right? You've got, or or something along those lines. That 20%, that's the like power users that are using the other weird, like, oh, there's this one feature buried deep down here. We can't get rid of that because it is actually useful, but 80% of the people aren't even using this. That's more how it gets used. And so for me personally, the way I apply this in like a day-to-day software practice and where I often butt heads with people is focus on that 20% that is meeting the needs of those 80% of users, because that is where like the meat of your product is. So if you're, say, replacing a service, start with that core 20%, because it's going to meet like 80% of the needs of the other side of the user, and then you can start adding on the extra bits as things go. More or less is how I describe that. It breaks down if you dig into it too deep, but it's a general like good kind of rule of thumb. And obviously, much like the last example, 80 and 20 are somewhat arbitrary, but it's about right.
Is this also related to that idea that of like the white whale in, or not the white whale, just the whales of a particular community or product, that like there are the 20%, there's a small portion of the people who use the product but use the most of it, and that's like they can give away the product for free, but the premium stuff is that they're counting on the whales who use it the most. Like most people use it a little bit. Some people use it a lot, and those are. I
haven't heard that term in that context. Usually, when I hear whales in that context, it's like in casinos, but it absolutely does apply that way.
Okay.
And given the nature of a lot of the types of games that would do what you just described, they
like
basically
mobile
are
games?
casinos. Yeah. Gotcha games, right?
Yeah.
Yeah, that's an excellent example of it. I think,
Okay.
right? You can get away with this free version because of that. The power users need that extra stuff.
Yeah.
Yeah. Or it's that 80. It could also be that 80% of the code is what everyone uses, and there's that weird 20%, right? You could flip it, and it's still valid.
Yeah,
But it's like 20% of your users are using the 20% of your software, or something like that.
Yeah, it feels like roughly what this is saying is that there is not an even distribution of like effort to usage or code to utility. It's that there's always this imbalance in either like the number of users who are using a certain amount of the product versus like, or how much effort you put into like there's not an even distribution of effort or usage in any software development program. And so you should really focus on, like you said, the part that is being used the most.
Yeah.
Or something like that. I don't know.
Yeah.
This one is always, I find it hard to explain this one.
Yeah. Because it doesn't hold
Clearly.
exactly true. It's like conceptually, it rings true for this type of scenario we're talking about. I found a rephrasing of this on Reddit from like 3 years ago that says 20% of efforts result in 80% of results. And that feels more right. I don't like the phrase efforts, but like 20% of your software is bringing in 80% of the use of your overall code. I'm like, yeah, and that matches more closely with how I do things.
Yeah, it makes it seem like a lot of the code in software is kind of like framework and fluff.
Yeah.
Like to make it a real boy, but really users care about, it's sort of like anytime you use, like, I mean, I don't use word processors anymore like Microsoft Word, but I use Google Docs, and 20% of Google Docs is like that I can create a document and type text into it and format it a little. But there's so much other code that does all kinds of insane stuff that I never use, and I think most people use that 20% of the code that allows you to open up a new document, type text in, and format it.
Yeah. I was going to use Excel as an example before you mentioned yours for exactly that reason. Like, I have done some crazy deep things in Excel that I would say probably more than 80% of users of Excel don't even know exist. And then there's things I don't know how to make, like pivot tables that are like a very like niche, like they're very applicable to certain things, and some people know them really well because they apply to that. And then there's me, and I'm like, I don't know. I'm sure that makes sense, but I don't care that much.
I feel the same way probably about like the program I'm using right now, Logic, to record this. I probably use about 20%. I feel like I'm in the 80% of people who use about 20% of this code. Yeah. And there's so many features that I don't even know exist. Yeah. They might make my life better, but like I get by just fine with knowing a small amount of it. You know, I hit record, I change some levels. But yeah.
That's how Audacity is for me. I open Audacity, I hit record, and when I'm done, I save it as a WAV file. That's it. Yeah. I don't do anything else in Audacity.
But it does can do so much more than that, Matt.
There are so many things that there's menu bar options that I've never touched. There's a transport menu option. I don't even know what that means. You can generate stuff. You can add effects. I don't do any of that stuff. The closest I've ever come to using effects in Audacity is to cut out background noise. That's it.
Yeah.
But you can, and that's the point, right?
Yeah, I think the more I think about it and the more you get into this, the more true it seems. It's like it becomes more self-evident the longer you work with software or build software and go through the cycle of making and having your users use the software and et cetera, et cetera. You know, I could even apply this to like making a song. Like I could spend 10 hours making a song and think about very minute details about it, like some mixing things, some you know, editing it just so, and someone might listen to like 5 seconds and be like, yeah, that's a cool song, and then stop it and move on to the next one. You know, there's a lot of effort that never gets seen in video games, like writers writing, you know, parts of the game
dialogue
that
trees,
so many people will never see because they're not that invested in the thing or something. Yeah,
or like you have to write the evil path, but you know, no one's going to go that way because it's too horrible. Like who's going to who's going to burn down the Jedi orphanage? Well,
somebody will.
Anakin.
Yeah. Okay. Okay. I'll take the next one. The Peter Principle.
I know this one very well.
They're using Dilbert or The Office as a example of this, but it is stated as in a hierarchy. So, you know, if you got your bosses and your boss's bosses and you, and if you have underlings, every employee tends to rise to his or her level of incompetence. And they have a comic here, and the boss is asking, how's your project going? And Dilbert says, do you mean the one that has no management support, ambiguous goals, no budget, and an angry team of overworked people who want it to die? And the boss says, no, the other one. And Dilbert says, sometimes there isn't an other one. I think I understand this, but honestly, I kind of want you to explain what you think of it. Like, how would you state this?
So I hate to give this guy any additional shout out after he went nuts, but Scott Adams wrote a book, who's the Dilbert author, wrote a book called
He is now deceased, though, Principle. So you're now speaking ill of the dead, potentially.
I'm not speaking ill of him at all in this context, although I have many ill things to say about him. Dilbert Principle is inspired by the Peter Principle, and it's since that not only is the Peter Principle true of, you know, you rise to your level of incompetence, and that's where you stop rising. And we can go into that specifically, but also that's why the promotion happens. It's a very cynical view on the Peter Principle, is that view. The least competent, least smart people are promoted simply because they're the ones you don't want doing the actual work, is the sort of the Dilbert Principle of this.
Oh.
Which is a very cynical take on this.
Yes.
But also has somewhat proven true. So the Peter Principle, if we perhaps play with that and pontificate, is you rise to your level of incompetence, right? And that typically is meant as a dig on management. Like, I think that's really where that comes out from, right? You're really good. You know, you could be a great engineer and like you keep getting promoted and you're like, man, this senior, oh, he's a staff engineer. Oh, he's an architect. This guy's great. Let's make him CTO. Well, CTO has very different responsibilities. Now they're doing the long-term technical vision for the company. Sure, that fits in, but they're also like the head of the hierarchy for the entire department, management-wise as well, often. Not always. I've worked at companies where CTO and like the head, like the executive vice president were different things for engineering, right? Yeah. But generally speaking, you can rise up. And then the reason you don't go above that is because you're not great at it. You stop when you hit your level of incompetence, where you are no longer great, which is why I often see at good companies that allow for this, people will like dip their toes in the water of management and be like, you know what? Not for me. and back out and go back to being individual contributors, which I think shows a lot of maturity. I have stringently avoided management, which has been definitely pushed on me multiple times throughout my career, because I know it's not necessarily that I won't be good at it. It's that it would burn me out somehow faster than all the other things I'm doing that burn me out. Like, I know it's not a sustainable thing that I can do. I'm actually a pretty good manager, but it weighs on me too much. So I won't go into it because I'm aware that I would become, I would not be as good at it as where I am now. Like, the level of contribution in the types of roles that I have is like, I will aim for the thing. I'm like, I know I'm good at this. I'm a great technical lead. I know that. I won't go from that to management because I know that little difference would absolutely put me in the Peter Principle, where I'm like, and I would never get promoted past that management to like director or CTO for the same reasons, right? My skill set is not in managing people. My skill set is whispering in the ear of the person who's managing things and being like, okay, this person's really unhappy, and I think we could do this to make, from a technical perspective, to be better.
So you're a little finger then?
I'm worm tongue, yeah.
Okay.
I am well aware that I am that person, and that is always viewed negatively, but I do it for good reasons. I try to help people with it as opposed to get my own motivations taken care of.
Yeah. So this came from, there's a book called The Peter Principle, and it's a concept in management developed by a Lawrence J. Peter. So he named it after himself. And so this summary on Wikipedia of it helps me understand. I mean, what you just said helps, but this kind of crystallizes it. So the Peter Principle states that a person who is competent at their job, so let's say you're a programmer, you're good at your job. If you're good at your job, you will earn a promotion and, like you said, go from, programmer to tech lead to architect, whatever. But if you get promoted to a new level and you lack the skill for that, you will not be promoted again. So basically, you get promoted up to a point where you now are not good anymore because you've been promoted too high, and then you get stuck. And that's called the Peters Plateau or final placement. So,
I like that Peters Plateau better than the Peter Principle. Like that is much more applicable, or much more intuitively you understand that.
Yeah, when it's said as you rise to your level of incompetence, that's a witty way to say it, but it wasn't clear to me exactly what that means. But I get it when you think of being promoted in a hierarchy, that, if you keep getting promoted, you will eventually, i.e., you reach a plateau where you are now out of your element and you are not good. And because you are not good, you will not keep getting promoted, and thus you will get stuck. So it's kind of like a paradox. Like, it almost seems like something that, unless you do something about it, it's an inevitable. It's a negative inevitability. And so it's almost like the inverse. Like, it's trying to teach you to do the inverse. Like, you don't want to get promoted after a certain point.
And that is active. That's something I actively do pay attention to. Like, I know what I am and am not good at. I'm a very introspective person, so I have a pretty good, and I've been doing this a long time. So I have a pretty good idea of where I would hit that line. And there's a couple of places where I'm like, nope, that's the wrong place for me. And I do push back on that. I'm like, no, that's the wrong move for the company to put me over there. This is where I should be. It's also where I will be happier. But because promotions tend to also be tied in with raises, it's, in most companies, fairly rare for someone to get promoted into a position. People recognize, hey, you know what? This is not their strong suit, and get demoted back because that feels bad. I consider it switching tracks, right? I switched to the management track.
Yeah.
And that track isn't right for me. I'm going back to the engineering track or the technical track. Like, then it doesn't feel as bad. And I just avoid the parts where I'm not good at it. But that's also true. Like, I've seen people get promoted into lead position, like technical leads, still very technical, that were great developers and just don't know how to delegate, don't have long-term vision. They're great at what they do, but they can't go past that. And there's nothing wrong with that. Right. It's good to know what you're good at. The people who sit in a cubicle all day and just pound out code, I am not that person. And if you need a person who's going to get from point A to point B quickly, I'm not that person. And I know this.
Yeah.
I would never apply for a job like that because I know that's not who I am. I'm a thoughtful person who's going to produce reliable code, and I'm going to with an eye towards maintainability and change, right? So that's me. I know where I am. Some people can't do what I do, but are great at, say, like down deep, like down in assembly type coding. I can't do that. Or databases. Like that's not my area of expertise. And so the same thing applies promotion wise. But, since I haven't mentioned it today, capitalism kind of keeps us from going backwards in that scenario,
there's some issues with capitalism.
Problem.
I think it has some flaws.
I hear that.
Yeah, so this kind of thing definitely, like, knowing where it came from, like the kind of stayed static by the book hierarchy of like large corporations that Scott Adams, the creator of Dilbert, would have, this prince, or sorry, he didn't come up with it, but he made it popular through Dilbert. Sorry.
I mean, I knew about the Peter Principle before Dilbert, but he added that corollary and I think really brought it into the like cultural zeitgeist of the time, which would probably be like early 2000s. If I had to guess,
I would have said earlier than that. I
Dilbert
would have said
Principle came
90s,
out.
but yeah,
it could be really late 90s, but I'm pretty sure I didn't read it until I was working at a like quote unquote real job, and that wasn't until 2000s.
Yeah, but it seems like one of those things where hopefully modern companies.
It was 1996. He wrote the Dilbert Principle in 1996. This year I graduated high school. I definitely would not have a clue about that.
But I mean, the Peter Principle was published in 1969, so it had already been around for decades by that point. Oops. But yeah, I can see why something like this would be thought of and solidified in that era. But now I would hope that this is something that I would hope is like internalized, like the notion of it to avoid this kind of thing. And like you said, thinking of promotions as more of a track or more of less of just like, oh, everybody starts in the mailroom and everybody's idea is to become the CEO. Like that seemed to be like a really basic, unnuanced vision of the hierarchy of a company. And now companies hopefully don't think of it like that simplistically, but I'm sure a lot of them still do, especially companies who have been around for a long time and their hierarchy is more calcified. But
exactly.
Yeah, so this is definitely something.
I agree. It is much more of a like IBM IBM corporate culture type mindset, and the 60s makes sense for why that would do it. Then today, where people I think are more mindful of this and there is a broader view given to it, I still think we know that there's still people out there that their entire drive is to get higher in the organization.
Always be
and the hierarchy.
Promote.
Yeah, and I will never be that person. And they're going to fall into this trap still. But I think generally speaking, people are better about that these days than they once were.
Okay, so that's the Peter Principle. We've only got 3 left. 3? No, we've got a few more left.
We've taken a lot of time.
Well, the Peter Principle is the biggest one, but I think we've got some that are coming up that maybe won't be as long. So why don't you take the next one?
Hofstadter's Law. Yeah. Hofstadter's Law is why we're taking so long.
True.
Kirchhoff's Principle.
Yeah, never heard
I don't
of
know this one. In cryptography, good, it's something I at least know about. In cryptography, a system should be secure even if everything about the system, except for a small piece of information, the key, is public knowledge. It's the main principle behind cryptography, right? Let's read that again because it was a weird way of saying it. In cryptography, a system should be secure even if everything about the system, except for a small piece of information. Okay, so a specific example of this I can think of is the etc password file on a Unix system. Mm-hmm. Used to be, like in the 90s, for sure, because that's when I was most using it. Used to be that anyone could read etc password on the system, any user. Yeah. Oof. And because this is not how it's done anymore, that is also where the encrypted version of the password lived. Now it's in like Etsy Shadow or something like that. It's been a while since I was a system administrator, so I'm not 100% sure about that. But the reason that it needed to be kept secure why you don't want those encrypted passwords to be available is someone can crack that, right? Even though the key's not out there, the key isn't available. Rainbow tables exist, right? These days, our like software is good enough and computers are powerful enough where you can actually crack a lot of passwords just by iterating through all the possible key combinations. That's why password requirements get longer and longer and now involve biometrics and multi-factor authentication, is because it's hard to do that. And it's because the system behind it isn't secure, right? If you don't have, if I leave my safe out on the street, even though no one knows the combination to my safe, it's not secure where the safe is. Someone can just take it home and drill into it, right? It's the same idea. So that there's not much to it, but it's a good point. Like, you got to secure the encrypted data, not just the key.
Seems
all those data breaches tend to be people getting access to that, and then it's how much were they able to crack out of it.
Yeah, it seems pretty obvious as a principle. It's not a law; it's a principle. It's something to keep in mind when you are designing something like public key cryptography.
Indeed.
Okay. Linus's law, named after Linus Torvalds, the creator of Linux. He states, given enough eyeballs, all bugs are shallow. I have never heard of this one before.
I haven't either, and I'm curious what they mean by bugs are shallow. I assume this it's actually Linus.
It's in the conclusion.
Linus's law.
So he's basically
my name is Linus Torvald, and I pronounce Linux. If you were really into building Linux systems in the late 90s, early 2000s, that is the sound you heard when you made your sound card work.
So just, for the broader audience here, Linux operating system, the code for it is open source. You can work on it. You can fix bugs in Linux. Linux is used in probably billions of devices, lots of embedded systems. I mean, I know 2026 is the year of the Linux desktop, just like 2025 was, and 2024 and 2023. But it's used in so many devices. Like my TV is a Sony TV. It's basically running Android, which is basically Linux. Yeah. But the thing, unlike the other two major operating systems, Mac OS and Windows, they are not open source. You cannot just go and fix a bug in Windows or look at the source code of how it was made. Neither can you do with Mac OS. Those are both proprietary. Linux, unlike that, is just on the internet. You can go look at the source code and how it works and fix it and monkey with it however you want. And Linus Torvalds, the guy who originally created it, is basically saying this is why it's so successful. This is why bugs are shallow, meaning that they are more easily discovered. When you have more people looking at the source code, he's basically saying why open source is a good thing.
Yeah.
Is that the more people looking at the code, the more transparent it is, the more things are going to be discovered. And, if we work out in the open and it's a community working on this, then we all help. It's much like humans that realize that, being a vagabond and never setting down roots was harder than if we set down roots and did agriculture and civilization. He's basically like saying that.
I think you mean nomad rather than vagabond, but yeah.
Sorry, yeah, nomad. Sorry. I got my synonym from that Metallica song, "Sad but True," wrong. Nomad, vagabond, call me what you will.
I found a good terse definition of shallow bug that I like. Mm-hmm. I think it's from Microsoft that has it, but it's a shallow bug is a software defect that is easy to spot, simple to reproduce, and straightforward to fix.
I like that.
The bugs I never get to see.
Yeah, that's not a lot of bugs. That's the ideal bug.
The Linus principle makes sense if you apply it there.
Is it
because,
Linus? Am I saying
the more
it wrong?
people that are. That was my point about the sound card earlier.
Okay, Linus, not the guy with the blanket from Peanuts. I'm sorry.
Yeah. Given enough eyeballs, all bugs are shallow. So Linux is something that engineers use, right? Most, especially back then, your normies, your average person is not going to be using Linux. But the people who
At least not knowingly, yeah.
Who are also the people who are most likely to notice these kind of shallow bugs and have the capability of fixing them. because it's open source. So that feedback loop, I think, is specifically what he was thinking about.
Yeah, and I think the popularity of Linux as an operating system in so many devices, not necessarily like the computer you use daily, but in so many devices, like all the Internet of Things in your house, most likely running some form of Linux, potentially, all the Android phones, et cetera, as we said. This seems to be true. Like it seems over time, it only becomes more true. It seems like a good thing. I love open source, so,
Wikipedia is kind of built on this idea, if you think about it.
Yeah, like any inaccuracies or typos, because so many people are looking at it, they get fixed quickly and are easily to spot and easy to reproduce, et cetera, et cetera. So,
exactly.
Yeah.
Which doesn't stop actual misinformation from getting in, just like it wouldn't stop deeper bugs from getting in. So I think that's a pretty good analogy.
Agreed.
Cool. Next one is possibly the most famous computer science law.
Yeah, the other M law that I mixed up Murphy's law with.
Yeah. Really? I never remember the name of this one or Conway's law. I just remember what they mean.
Go wrong.
Yeah. Hey, there you go. Moore's law, Moore, but also kind of works as the homonym Moore, More.
Yeah.
Moore's law. The power of computers per unit cost doubles every 24 months, right? And it really went back to like the number of transistors on an integrated circuit every 18 months or something. I don't know anything about that. That gets down to hardware stuff that I'm not good at. I like this version that they have on here. The processing speed of computers will double every 2 years. And that roughly has proved out. Maybe not exactly 24 months, maybe not exactly double, but look at the capabilities of your iPhone compared to my big old computer I had in 1988 or 87 rather. Huge difference.
Yeah.
I just every bit of capability about that, size, storage capacity, processing power, everything is so much. It's science fiction compared to what I had in 87.
Right. Yeah, the kind of device that your phone is now, yeah, like 30, 40 years ago would not have been, yeah, it would have been science fiction. But the thing that I think of when I think of Moore's Law, because yeah, I've heard of this one. I've heard it for a long time. Apparently it was Gordon Moore, the co-founder of Intel, is the one who coined this.
Makes sense.
Yeah, I mean, he was dealing with processors, but I was just thinking.
I first learned about this on Slashdot. If that tells you how
Slashdot's
long
still
ago
around.
I learned about it.
Yeah, but I'm thinking like, is this kind of a? I don't know if this is this logarithmic? Yeah, I guess this is or exponential. But regardless of which way, whether it's the upwards hockey stick or but does it not have an asymptote that it will eventually reach? A plateau, like where this can't possibly keep happening in perpetuity.
I don't know. If it's actually exponential, then no. It would go forever. However, there has to be some physical limitation of, like, the speed of light, right, is going to slow you down at some point.
Right.
Unless we get into quantum computing, and then that's the whole thing. So right now, but it seems to actually be, if I look at, I searched for graph Moore's Law, it does seem to actually be more linear than anything else. It's not growing exponentially, which makes more sense. It seems like because it's just doubling every 2 years. Yeah, okay, that's linear. I don't know where the equation they have on that image is an exponential equation. Oh, but it's just 2 squared. Okay, it's not, n isn't in there. Yeah, it's just a linear equation.
It is a linear equation, yeah.
So at some point we are going to hit the problem of like the speed of light or some other, like you're going to hit the part where your computer parts are atomic and you can't get any finer than that.
Right. I mean, literal physical space is a limit in how closely you can smush things together. Even at the atomic level, there is a limit at some point. But like, it's one of those things where like, will we hit it in the next 50 years, 500 years? I don't know. I mean, I guess if this is true and it doubles, eventually you could extrapolate this to like, oh, well, in 3050, we will no longer be able to smush two atoms together any closer because that's how that works. I don't know.
Presumably, we will have figured out a way around that if it's possible by then. But if there are physical laws of the universe preventing you from growing or getting faster, that would be the end.
Yeah, but thus far, apparently we're not anywhere close to that, but maybe someday. As a corollary to Moore's law, I have never heard of this one, which is Wirth's law, W-I-R-T-H, not W-O-R-T-H, states software gets slower faster than hardware gets faster. And the author said, take that, Moore's law. So this is sort of like, no matter how many processes were doubling every 2 years, the software somehow gets slower, which kind of makes it seem like, and I've seen this example, or I've seen this complaint that like, dude, my computer has 16 cores and I've got a NVIDIA 9 billion RTX whatever, and yet there's Flickr in Google Docs or something like that. Somehow, either through bad optimization, which is what I've heard a lot of, or just pushing the limits of that hardware way more than people used to, or bad programming, who knows, software seems slower, like using Slack, an Electron app, somehow feels sluggish despite the fact that I'm on like an M4. Like, what's the deal, bro? So
laziness
is it laziness,
right?
I mean, is it bad programming?
Not necessarily bad programming, but it's laziness. And you can take AI as a good example, but I'll go back further than that and to tie it back into game dev. Haha.
Finally.
Look at Metroid for the NES.
Sure.
Look at the capabilities of that thing and the limited capabilities of the NES.
Yeah.
And then look at Super Metroid. It seems like a natural progression, right? It seems like you improve the graphics, it's a bigger scope, blah, 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 blah. You got more buttons, right? And the reason that they were able to do that is that the developers were very conscious of the limited tiny space that they had and were packing things together and doing clever tricks like in Mario, the clouds and the bushes are the same sprite, just different colors, right? Mm-hmm. They were being very mindful of that. Well, now we're developing in like Godot, which is a high-level language and has a whole bunch of stuff behind the scenes, and it's not as optimized. And this is also true of programming languages like Python or Ruby or any interpreted language where like we're not compiling it down in the most optimized fashion. It's not written in C, right? Because I've been lamenting for years that I just want Super Metroid huge. I want an entire open world type Super Metroid with that level of graphics is fine. I don't need, but what happens is, I can make that prettier. I can put sound in here. I can do an actual voice. Look at this actual motion. Remember when you would get games that just produced actual movies in the middle of them? Like here's a .mov file or AVI. Mm-hmm. And that's why, right? You kind of grow into the space that you have. But if we wanted to, we could take those things, really like dissect them and optimize them and shrink them down so that they could run on older devices well, and then they'd run really well on yours. But what's the point? If everyone has a supercomputer in their pocket, why do we need to worry about 64K RAM, right?
Yeah. So basically you're saying this is a true law and it's our fault as programmers.
Yeah. I mean, why not, right? Look at, again, stick with games. Look at Axiom Verge and like the kind of things it could do. It didn't try to go with the high-res images. It's very sprite-based. It looks like an old Metroid game. And it does have that much bigger world. Mm-hmm. So you were able to do things more efficiently than they would be if you went with the full motion 3D, 2.5D, whatever rendered background, and because a lot of 2D games or 3D games are running in 3D engines, and just the camera's stuck here.
Yes, I've seen some like breakdowns of something that's done in Unity that has like depth. It has like 3D depth, but they like only show 2.5D or even 2. Yeah.
Yeah, Metroid Other M was one of those.
Oh, do not speak of that one. I never actually played that one, but I've only heard negative things about it. No.
It wasn't as bad as people say.
Okay.
All right. What do we got next? The 99 rule, which I have only ever heard called the 90-10 rule, which is sort of along the lines of the 80-20 rule. I think I conflate these two things into the same thing.
Ooh. All right.
But it
What's
says
the 99
the
rule?
first 90% of the code takes 10% of the time. The remaining 10% takes the other 90% of the time. Absolutely.
Yeah.
Right? You write your code, and this would only really be true of like production software, I think. I don't think you're going to get this from like a script that you wrote, right? Like that's just sitting on your computer doing something. Because really what the other 90% of the time is all the bugs and the edge cases and
the polish.
like, nice to have, the polish, the nice to haves, the quality of life stuff. That's a lot of work that people don't really appreciate. Most people don't really appreciate. I love that stuff. Like that's the reason I don't buy games in early access. I want that last 90%. I want that last 10% of stuff that takes 90% of the time. I want that spit and polish. I don't want my game to crash. I want it to be a fun, seamless experience.
Well, to use a recent example of which I believe you might be alluding to is a new game called Subnautica 2 just came out a couple days in, and it came out in early access. Now, the original Subnautica 1 I played, and its DLC I played, and I enjoyed both of them, so I was super hyped about this. There has been a lot of drama in the development of this game. It almost seemed like it wasn't going to get made or released because there was, you can go read up the drama on your own, but so it feels kind of a miracle that it came out at all. And because I'm a super fan, I wanted to play it even though it was in early access. And in general, I would probably take more of your tact on something like this. Like, because there's so many games to play, I could play plenty of games that are, gold finished and not early access. Why would I spend my time on this? But, if you're a big fan and it's polished enough, and I would say putting about 11 hours into it so far, it feels really polished. It does not feel like what you might think an early access game is. And I think that says a lot about the development team themselves, that it is so good this quote unquote early, because they have a roadmap that stretches out 2 years. So there's a lot of stuff they're going to add, but I think the guts, the core, the first 90% of the code, I think that seems a little high. I'll put more about 75, 80% of the code, but like the system, the mechanics, the basic visuals, the sound, all of that seems done to me. So what they're going to add, like I said, is probably like quality of life improvements, features, new enemies, maybe new weapons, new tools, new biomes, more story. They're going to expand the world, but what they have so far is good enough. And so, I completely agree that this 90-90 rule, 90-10 rule, whatever you want to call it, is very true. That, I just... the person that wrote this article even says, so true. Anyone who does not agree with this? ? Yeah. It's hard to argue against this if you
I think
have developed.
People who haven't done software engineering, right? If you're just like tooling around on your computer, you're probably like, no, it doesn't. But if you're trying to make the system robust at all, it's super true.
Yeah. Okay, we have two more laws that we wanted to get to. The next one is Knuth's optimization principle. That is Donald Knuth, right? Isn't he
maybe
the creator of C or something like that? He's a big name in computer science.
Something like that. He is... it doesn't say what he's famous for, but yeah. He wrote The Art of Computer Programming. That's what I know his name from.
Okay, so he's a programmer known for a classic instructional tome. I thought he invented some programming language. I could have swore he did.
He created Web and C-Web, whatever those are.
That's not what I've known him from. Anyway, he is still alive. I don't know why I thought he passed away. He's from Milwaukee, Wisconsin. My dad is from Wisconsin. Woo. That's awesome. So Donald Knuth? Donald Knuth.
Yeah.
Or is it Knuth? Because the IPA of this actually looks like it's Knuth.
Who could know?
I don't know. Anyway, his law is his principle, Knuth's optimization principle, i.e., premature optimization is the root of all evil. This definitely feels true to me as this is almost like this almost feels related to the 90-90 rule in that do that first 90% of the code that makes the thing run and is useful and good and people want to use. Do not worry about making it the best. Do not worry about, refactoring it, doing something slightly nicer than before. Just get it working and awesome, and then go back and optimize it. Am I right in reading that?
Yeah, that's exactly what it is. It is Knuth, by the way. I looked it up.
Knuth. Donald Knuth.
Yeah. Yes, exactly what you described is right. It's something I am well aware of, and also one of my biggest failures as an engineer is premature.
I was going to say I have a hard time sticking to this. Yes,
I am notorious for this. This is the reason I have aim for success, not perfection, on as a sticky note on my monitors to remind me about that. I have a bad habit due to years, beaten dog syndrome, I think is what this is called, right? I have years of getting punished, basically, for not having optimized my code.
Oh.
Particularly architecturally. Like, they're talking more speed, but I think it applies generally, right?
Yeah.
I will tend to over-engineer a problem to avoid the situation where later I might have to do a thing. So, for example, we, at my current job, switched from one source control system to GitHub. The amount of work it was to separate, decouple all the various pieces of software from that SCM were so frustrating. So when I replaced it, I replaced everything with an SCM layer like class, and then I had subclasses for the different things, which is how you build things. Well, now we only have GitHub, and now that SCM layer is in the way every single time. You're like, oh, let's look at, get commit. SCM.get commit is a stub class you have to implement. It's an abstract base class. So it doesn't skip to GitHub when you right click and go to definition. So, like, did I prematurely optimize? No, because it was actually necessary for the transition there. But now that optimization is in my way. So then you have the question of, do I get rid of that layer? And if so, what will that do when I do have to eventually go to whatever the GitHub replacement is in the future? Who knows, right? Because that would be an example of premature optimization. Maybe.
Yeah. This reminds me of another term that I heard a while ago called YAGNI, i.e. you
ain't gonna need it.
You ain't going to need it. And that goes right along with this, where it's almost like the longer you're a developer, those years of experience work against you because you are constantly trying to prepare, which is one of the laws, is that you should always be prepared for things to go wrong. And so if the last time I did this, a thing happened, so I should definitely prematurely optimize this project because of that thing that happened before. But then you find out you ain't gonna need it, and you wasted all that time doing that. It's a spectrum, it's a line on which you kind of decide how much or how little of a thing you're gonna do. Yeah. And this principle is at least stop for a second and think, no, most likely you will not need to do that. And so just do the thing that gets the job done, and don't worry about building all this. Maybe you'll need it. Maybe it will be useful. Maybe it will make it better artifice that you may be stuck with later and have to deal with. And then you're like, well, now do I get rid of this? Well, now it's kind of become part of the system. So yeah, that's kind of what I think this is saying.
Yeah. I talk a lot about trade-offs when I talk about software architecture and software design. That's what this is, really. Yeah. Like, do I optimize this now and risk it being too early, or not optimize it and risk it being too slow to be functional, right? Or it having such a unoptimizable code path that it's prohibitively expensive to optimize it, right?
Yeah.
And that's a legitimate trade-off decision when you're developing something. Sometimes speed to production is more important than the other illities in software.
Yeah, I mean, sometimes you just need a thing that does a thing as soon as possible because otherwise the rest of it is going to blow up, or you're not going to get that contract or something. I mean, this is something that, once again, to tie it into game dev, like I know there's a long history of companies who are working on a game and they want to get it out in front of the people so that they can get support, feedback, so that their publisher is
Make
happy.
Money.
Yeah, to keep getting money so they can keep working on it. And so they may send out something that's definitely not optimized, but they can export a video, a 30-second video that looks amazing, but doesn't actually run on anybody's computer yet because they haven't optimized it.
It's a tech demo.
Yeah, it's a tech demo. But, but it was important and it had a use. And so, yeah, these are the kinds of, like you said, the trade-offs. These are the kinds of decisions that really is what you as a software developer or architect or engineer are doing with your time, and not just coding. You're trying to make these decisions about how you should code, not necessarily actually doing the coding. So yeah, this seems very true. Hard to argue against this, but also it's a spectrum, and that's the decision you have to make as your chosen task.
Yeah, and modern development using LLMs makes this decision very different, right? Because you can now get to that first step by vibe coding or whatever, and then optimize afterwards. And that's what a lot of people do. And that kind of falls into my motto of make it work, then make it work better.
Yeah.
That should probably be Messerman's law, but that's more of it's more prescriptive than a law.
Yeah.
Yeah.
All right. We got one
Final
more law.
law?
I've never heard of this law.
All right.
Hopefully
Me
you
either.
have. Okay, great.
Nope. It's, but I did bring up some information so I could talk about it because I didn't understand it.
Okay.
I didn't even know what it meant. So Norvig's law is a humorous yet pragmatic business truism coined by computer scientist Peter Norvig, and it states, any technology that surpasses 50% penetration will never double again. What the heck does that mean?
Yeah, what does that mean?
I don't know what most of those terms mean because they're more businessy than software-y. It specifically has to do with evaluating growth and market claims. So the breakdown I saw about it was once a product or service reaches 50% of its target market, which is what they mean by penetration. So like if you're selling things to 40-year-old men and 50% of the potential user base there is using your product, you have 50% penetration. It is physically impossible for the remaining user base to be large enough to allow for another doubling. I'm assuming there they mean of sales, right? Because if you double it, you hit 100%.
Right.
You can't, and you're never going to have 100%. So it's a truism in that it doesn't, like, duh. it's a tautology.
Yeah, I mean, I don't really understand where the applicability of this law. This feels more like an observation.
Yeah.
I don't know.
So it's supposed to be a nudge to apply critical thinking to claims that are like, it's all businessy stuff, right? It's all marketing and sales BS money, which is why it's not important.
I mean, does this have any applicability to actual software development itself?
No, it has to do with how you're selling the software, I think. So it's a terrible one to end on.
It really is. Wow, maybe I'll cut this out.
For real life, we're going to end, we'll mention it, but the real thing we're ending on is Knuth's optimization principle. That's the good one.
Okay.
Norvig, sorry, man. It's a cool observation, but I couldn't care less about the sales and marketing side of things from a software development perspective.
Yeah, I'm sure if we looked into it harder, we could maybe tie it in, but you know what? I'm not going to do it. Nope. So that's all the laws. We got through all the laws that this one... are there any laws that... I mean, I know we came up with some sort of like that internet theorem of like, if you want to know the answer to something, post the incorrect thing and everybody will correct you. I don't know if that's an actual law, but do you know of any other laws that you'd want to add to this?
Perfect is the enemy of good. No, perfect is the enemy of done. That's what it is, which is another way of saying aim for success, not perfection. My old boss had a sign, like this was 20-something years ago, on her wall that said, aim for success, not perfection. And also, perfect is the enemy of done. And they're both true. And super important to remember when you're doing software development.
Yeah, I mean, according to the first Google hit, this is attributed to Voltaire.
Really?
I feel like he probably didn't write it that exact way, but I mean,
Well, I think
this
he
also
was French, so.
yeah, this also he probably wrote it in French. It also feels like that thing that I heard a long time ago might have been attributed to Google, like when they started doing moonshots. But the thing they said about it was aim for the moon, land in the stars. It's sort of like you're all.
I thought it was the other way around.
Aim for the stars, land on the moon. I don't know.
Yeah, aim for the stars and you'll reach the moon or something like that.
Okay, but it feels similar.
Same
where
idea.
You're shooting for some higher ideal, but you are really just trying to improve. And so
Shoot
set
for
your
the
aims.
stars, aim at the moon.
Sure, stars, moon, done, perfect, good enough.
Yeah. Lucky Charms.
We out. Okay. Well, if this was on YouTube, I would say, tell us in the comments your favorite laws and whether you agree or disagree with anything we said. And it is on YouTube.
Oh.
We're on YouTube. I forgot.
Hey, we are.
I don't think anybody leaves comments, but hey, you should check it out on YouTube.
You were right. The earlier quote is Norman Vincent Peale, whoever he is, said, "Shoot for the moon. Even if you miss, you'll land among the stars."
Okay. Yeah. So I got
I like that one.
Yeah, I got the order of the subjects wrong, but in general, yeah, like also my favorite one that's just like that is art is never done, only abandoned.
Yeah, you say that a lot. And
I
like
say that a lot because
a
it's
lot.
true. But it's the same thing as perfect as the enemy have done. There's no such thing as a fully 100% complete, perfect. What's the Greek philosopher? Not Socratic. Oh, Platonic. Like the Platonic ideal of a thing is the perfect version of it, and it is impossible. And so you should aim for it, but not actually try to hit it because you will never finish.
Yeah, go for it. Make that your goal, but be willing to settle before then when it's good enough.
Exactly. We're very good at reiterating and restating the same few words.
Mr. Right versus Mr. Right Now, as the probably Sex in the City.
Yes.
Where that's from.
Yes. Okay. I think that's enough
And on
about
that note,
I think that's enough about laws. This has been way too legal of a discussion. Go out and break some laws. No, sorry, I didn't say that. Don't do that.
hack the planet.
Hack the planet. Hack the Grepson. Hack the Gibson. Just hack it all, but do it legally. And if you don't do it legally, you didn't hear it from us.
But we will be your alibi. So.
Thank you for joining us on this episode of Hacking the Grepson, where we talked more about the fundamental laws of software development. You can listen to more of our episodes on hackingthegrepson.com. We try to put out an episode every other week on Wednesday. We have over 100 episodes. Go listen to them. They're awesome. On YouTube, on podcast apps of your choice. And until we next talk at you, we now return you to your regularly scheduled lives already in progress.